All right. Thanks for everybody coming. We appreciate it. Another great turnout. It's been a really good year for Holley EFI and racing. A lot of people won a lot of races, set a lot of records. I see some of you guys that have done that in here. We really appreciate it. We appreciate our customers, our dealers, and everybody that supports it. I'm Doug. I'm not going to speak too long here. Ryan is going to be putting on the seminar this year again. He did a great job last year. And hope find what Ryan says, something to learn and interesting. So appreciate it. Going to give it off to Ryan here.
Thanks, Doug. Can everyone hear me fine? So I'm just go ahead and get right into it. This year, we're going to start with just going over some of the new products and how they integrate with the Holley EFI software. Some of the things we're going to cover are the USB to CAN dongle, the newer high-flow boost control solenoids, the injector driver modules for external drivers. That's for your low-impedance injectors, your big methanol injectors. CAN EGT modules, the Pro Dash and some of the features it has where it works with the Holley EFI now. The MSD Pro 600 ignition, I know a few of you in here, I see I've talked to you already about that. And then the smart wire and the Racepak V300 and using them on the Holley CAN versus the third-party Racepak protocol. After that, we'll talk a little bit about the V5 software. We'll go over the new cam ignore feature, 300 frame per second logging, the logging format change. We changed the naming convention on the logs. We'll go over some of the stage injection features of V5, and we'll cover the traction control. Traction control will actually be covering the perfect pass, the active speed management feature, as well as comparative wheel speed controls and how we recommend to do that and how we did it on Doug's car actually. So the USB CAN dongle, it's been around for a while. It's something we started using on the snipers. We use it with Terminator X. We now, with V5, we added it for V5 as well. What it does is it allows you to communicate with the ECU via the CAN bus as opposed to the USB port on the ECU. In most cases, the USB port is going to be faster and better. There's some instances where the USB CAN is preferable. One is doing firmware updates. I don't know how many of you have done a firmware update in here, but they take a while when you're using the USB. If you use the USB to CAN dongle, the firmware update in total takes under 5 minutes. It's almost worth it just for that. Another thing it does is if you somehow damage the USB port, hopefully that never happens to you, but if it does, using this allows you to still maintain full functionality of the ECU. Next up is the high-flow boost control solenoids. This is something we worked on. I think we released it last year technically. We worked with Mac Valves and our vendor to come up with a higher flow valve than what the competitors on the market and what was standard available. From that, we ended up with a valve that flows 90% more than the standard 3-port Mac valve that we sold previously and still sell. It flows 40% more than the comparable bullet valves on the market. What that means is if you're trying to get all the boost in immediately, if you're in a boost limited class, power limited class, and you need to ramp your boost as fast as possible, these solenoids will allow you to do it better than others. Another side benefit is typically you can get better control of the system. They're also supported in Terminator X. It's available as a drop-down in V5. The injector driver modules, this was designed to fill a need with basically the 700-pound billet atomizers is what made this product come to market. It's available, it can do 4-to-1, 8-to-2, and 10-to-2.5 amp drives. That's just the peak and hold settings. When you hear people talk about an injector and they say it's low impedance, it's one of these. It's either a 4-and-1 or an 8-and-2 typically. Most of your bigger injectors from billet atomizer are 8-and-2. Another thing we did with this injector driver is it allows you to hold the peak duration for half a millisecond or 1 millisecond. What that means is typically a peak and hold injector will run up, and as soon as it sees the peak amperage, it drops to the hold. So in an 8-and-2, the second you create 8 amps in the circuit, it drops immediately to 2 amps. With this, it will hit 8 amps, hold at 8 amps for either half a millisecond or 1 millisecond, and then drop to the hold setting. Where this really matters is on a 700-pound injector. The 700-pound injectors will hit peak current in most instances, depending on voltage, before the pintle is fully open. So what that means is the injector is still opening and trying to spray more fuel while it's dropping to the hold current. So the time you want the peak current and the most power going to the injector, it drops out and goes into basically an idle mode. So adding a 1 millisecond peak hold fixes that. So now we are after the valve, the pintle is fully open before we drop to the hold current. Injector driver module also has a test fire mode, so you can flip the dip switches on the back of it, hold the button down, and it will fire each injector for, I believe, 1 millisecond in a row sequentially, so you can verify that your wiring is correct and that each injector is firing. Also has diagnostic outputs. What this is right now is there's 2 wires you wire into the ECU, and it will basically give you varying voltages to tell you what the codes are. We're currently working on adding CAN functionality to this, so you'll be able to just plug in over the CAN and pull the diagnostics that way. We also have a terminated harness that should be releasing in the next month that will already have the super seal for the injector driver. It will have the 10-pin Metro Pack that connects to our pre-made injector harnesses, and it will also have the ECU connectors to plug into the J2B connector as designed in V5 stage injection, which I'll show you later. Our CAN EGT modules came out this year. We have both an 8-channel and a single channel. Very, very easy install on these is the biggest selling point. There's one connector, and then you just go into the inputs and create your channels. The 8-channel module, as you'd guess, is pretty much for per cylinder exhaust gas measurement. The 1-channel is actually really good for something like a methanol turbo car where you need a higher range on your IAT. It's also good for cylinder head temps, oil temps, pretty much most temperatures you want to measure. You can use a thermocouple. If a thermistor just doesn't fit your needs, using one of the CAN EGTs with the right thermocouple is what you need. The modules are compatible with pretty much any K-type thermocouple as long as it is ungrounded. You very rarely will see a grounded thermocouple in our industry. It's compatible Racepak cells, a large amount of the varying sensors. One of them is pictured here as a cylinder head temperature. You can also find things like we have one designed for IAT, we have one that's a patch that you can pretty much glue on to whatever you need to get a temperature. And these are also supported in Terminator X. Quick screenshot of how it looks in the software. On the left, you'll see you create an input and select CAN as the type, name it as you wish. And then on the right is the setup screen. You'll go to the CAN device, select 8-channel EGT or single channel, depending on which you have. Select the CAN channel, which bus you're on. If you're on a Dominator, you have the option of CAN bus 1 or 2. Critical you get that right, otherwise it won't work. And then also the CAN serial number is the other big thing. That will be printed on your device, and you enter that in so it knows where to find it and get the information from it. Pro Dash, both 12.3 and 686 have been released this year. One of the biggest things with them is they have a universal firmware, meaning you can plug it into a Sniper, a Terminator X, or an HP Dominator, and it will work without having to reflash it. One of the things that also came along with that is you can now take an input that you're logging to the dash. So some of you know on the back of the dash is a connector, and you can hook up sensors, either 5-volt or thermistors, to them and display them on the dash. Now you can take that information over CAN and log it in the software. You can use it in an advanced table. It's part of the inputs, just like a native input would be. Also along with that is GPS information is available in the software via CAN, and then IMU information, which would be your accelerometer and your gyro. There's up to 13 inputs you can log into the Holley software on one of the Pro Dashes. And like I said already, you can use it in advanced tables. Quick picture of what that looks like. As we showed earlier, you select CAN as your type and then go to the setup screen. And then you'll have the option of the Pro Dash IMU, GPS, inputs A or inputs B. This one is the IMU. You can see your options for it are the accelerometer, axes, the gyro, and tilt. And then I just also showed Pro Dash inputs A, that's input 1 through 8 on the dash. Input B is just the additional 9 through 13. The MSD Pro 600 is another thing we came out with this year. It's been a real hit, works really well. It's capable of 680 millijoules max output. That's not sustained. 600 millijoules sustained is what it will do, and that's days on end. I've had it running at my desk at that, 7,000 RPMs, and just left it for hours on end. Gets warm to the touch, that's it. It's compatible with a power grid and a profiler. Compatible with most EFI systems. We say most because we haven't tested all of them. Pretty much any EFI system that has individual EST outputs, meaning it can run smart coils or run an LS or anything like that, will be able to work with this. It's got 2 selectable power levels. It's basically a ground wire. If you ground it, it switches between high and low power. Low power is roughly 300 millijoules, and the high power is defaulted at 600 millijoules. If you use it with a Holley EFI, you gain the ability to use a table where you can set the power level based on either basically 2 axes, whatever you want, RPM, TPS, map, wheel speed if you want, anything. Has an AC spark profile, which is unique compared to the competition and an IGN-1 smart coil. They're all DC. AC is a little more immune to cylinder pressure as far as the spark duration. What that basically means is as your cylinder pressure goes up, your spark duration doesn't shrink as much as a DC profile would. Shown here is just the output setup on the bottom. There's a new type in the software called MSD Pro 600-8 that will enable all of the settings for it. Below you have to set your axes for the power table. On the left you'll see under the system parameters where it says ignition power on the 4th one down. Typically that will say dwell if you are using another ignition type. We take that table and repurpose it for ignition power when used with the Pro 600. This is the example of the ignition power table. As you can see, it's just a percent of total power in the table. I chose RPM and map for the axes. We allow you to go to 105% in the table. 100% is equal to 600 millijoules. We give you a little bit over in there if you want it, if you're not going to use it for sustained use. The minimum in the table is 30%. Most people really aren't going to need this. This is more for your drag week type of guy or someone with a very limited battery. If you have a small battery in the car, this ignition does pull a lot of amperage, so you may want to lower the power level just to save the power for the actual drag strip run. You can also increase past the 105% by using an advanced table to additionally add more percentage to the table. It will allow you to enter obscenely large percents, but the Pro 600 will limit itself at 680 if you go past it. We also have all the diagnostics that come with Holley EFI when using the Pro 600. This is just the example of all of them listed out. You have your normal stuff like temperature, battery voltage at the Pro 600. The converter voltage and energy is basically, we say 600 millijoules. This is a measurement. You can watch it in the data log and see that it's actually getting there. The fault mask is fault codes. Typically that thing should stay at 0. If it does not, in the instructions is listed out how to decode what it is, or you can always call our tech department. Beyond that, we have misfire counters, spark period, and efficiencies. These are basic feedback from the ignition. You have your spark period and your efficiency, which are both how long did it take for the first wave of the AC energy to get to the coil and back. You can use that as a measure of how much load's on the ignition. Similar to efficiency, efficiency is the actual percent of energy recovered at the converter for the next strike. That can also be used. What you'll use both of those for more times than not is you're looking for trends. Run after run after run, as you have your car, you have your tune-up, you know what it's supposed to do in every other way. You'll look at these numbers and they should be the same run to run to run to run. If they're not, you can start chasing a problem with a specific cylinder. If you see one cylinder, suddenly the efficiency is way higher or lower than another, you need to start looking either at the engine itself or the ignition system to see what's going on. The misfire counter is basically open load detection. So if the spark period ends up way too long, it will start incrementing a counter for that, and you'll know you have basically a misfire or the gap is jumping somewhere else other than the cylinder. So that one, the misfire counter is good for a gross problem. to just nail down which cylinder it is. Next is Racepak and Holley EFI. The universal EFI module used for connecting Racepak to Holley EFI has, in the latest version of it, in the latest version of Racepak software, has the ability to use the Holley CAN bus as opposed to having to select the Racepak CAN previously. What this means is you no longer have to choose on an HP if you're going to run Racepak product or Holley product. Previously, it was an issue if you wanted to run a smart wire on a Holley dash on an HP, there was no good way to do it. So this fixes that issue. So as you can see here, it's just a picture of the CAN buses. We have Holley Standard and Racepak. Previously, you would have to select Racepak to use a Racepak product. Now you do not. You can use Holley Standard with it. This is just showing on the Racepak side when you configure the universal EFI module, the selections you can see on the far right is Holley Dominator Racepak, which is the previous one, Holley Dominator V4 Standard, which will work with V4 or V5 with the exception of Build 30, which is out of production at this point. Most shouldn't be running it. And it will also work with the Holley Sniper. Next up is the cam sync ignore after start setting. You can see in the cam sensor type in the middle of the page, we added a new drop down. It says single pulse ignore cam after start. What this does is it uses the cam sensor to start up the engine, set the sequential mode, set the firing order, and just basically gets you running like it always has. And then as soon as you exceed the crank to run RPM in the software, it will shut off the cam sensor and no longer look at it until you restart the engine. So what this can mean is, for all of you guys that are going down the racetrack and have had a cam sensor issue in the past, it used to shut off the motor. Now it won't. Now you'll get back to the pits and go to start it for the next run and it won't start then, is what that really means. But you win your round. Hopefully part of your program is warming up the car before the next round. You'll find it then with enough time to fix it. Currently, this is only available with a 1 pulse per fire crank sensor. We don't recommend that you use this for coil near plug. A lot will. It'll work fine. The reason we don't recommend that is simply because if you do lose a cam pulse along the run, you basically jump the firing order. So now you'll be 1 cylinder off in your firing order, which usually ends up in a big boom. So this is something we've had a lot of requests for. I actually pushed for it myself, but it is something with a little bit of risk. So decide if it's right for your program before selecting it. Another thing we did with V5 is we updated the logging rate to allow for up to 300 frames per second. Along with that came much bigger logs. So the next thing we did was change it so that when you create a log less than 60 seconds, it doesn't overwrite itself. The way we did that is the former log format. So on the left side, you see this is the new log format. So it was the 5th day of December and it was 16:47 p.m. and 45 seconds. So by doing that, you can now take a 15-second log and you'll end up with 4 logs in a minute, as opposed to previously you'd end up with 1 log of the last 15 seconds. So that's the end of the slideshow. From there, I'd like to show you some of our traction control stuff. And this is actually, as I said earlier, this is out of Doug's car. He went to a no prep race this year and decided to try it out. So we decided to try something new and do a wheel speed traction control combined with the drive shaft speed. So what I'm going to do is just poke through the calibration a little bit, make sure I decipher everything correctly, and then we'll look at the log and see how it actually played out on a run. So the first thing we'll do is we'll go to the traction ICF and we'll just look through the settings here. We'll see that he's using the drive shaft input of rear wheel drive shaft RPM. He has a minimum drive shaft activation of 5 RPM and a maximum of 12,000 RPM, which means that below 5 RPM, no matter what we have in the tables I'll show you in a minute, it won't do anything until it exceeds 5 RPM. His x-axis max time is 8 seconds, which means when we look at the tables, they will be 8 seconds long. And then the timer ignore is 1/10 of a second, which means 1/10 from the time of the trans brake release, it won't take any action on the drive shaft curve or the crankshaft curve, no matter what it is doing. Take a look at the crankshaft curve. We'll see that it's disabled, so it should not be doing anything in the data log when we look at it. You see there is a curve in there, looks like for about 1.5 seconds. One thing, I don't know if you were thinking about doing it at the time or we talked about it, but one thing people can do is you can use this to make sure the engine RPM does what you expected it to on a run. If you make some changes to your converter or some bleeds or, make any change that you're not sure where the RPM is going to roll over or how your converter is going to act or how that front part of the run, the RPM is going to move, you can put in what you want the engine RPM to be and use timing or a rev limiter to control it and keep it there. Look at the drive shaft curve, see what he has in here. So drive shaft is enabled. There is a base curve in here. So the base curve would be most likely from another run what you actually wanted it to do. You'd import it, put it in here, and you base all of your other curves off of it. So we can see he only goes to about 2.7 seconds. As you can see in the top left of the graph, there's a little yellow box that shows the time and the RPM of where your cursor is. So I'm just kind of hovering it over there saying it's 2.7 seconds. If we go up to the top here, we can see at 2.7, it's 3,591 RPM. So we'll look at next the retard A curve, which is your first step of retard if traction control is activated. And I'm actually going to activate the deltas to see how much above the base curve it is. So it would appear that for the most part he's 75 RPM above the base curve. So basically, if it goes 75 RPM over that baseline, it's going to start pulling timing. And it appears that it only does this for 2.68 seconds, as you can see here, and at 2.7 he effectively disables it by moving it way out of the way. So down here we'll look at what he's doing if you encounter that line. So what happens if the drive shaft curve comes up and rolls through that line, meaning it gets above the number in the table, which is 75 above something, but the actual number is here. So 1.02 seconds, if the drive shaft curve goes to 1608 RPM, it's going to step out an amount of timing. So we'll come down here and look at 1.2 seconds, and we'll see that it will step out 4 degrees of timing immediately if he exceeds that curve. Retard B will do the same thing. We'll just look at it. Looks like it's roughly 200 to 150 over the base curve, so it's roughly double the retard A. Since retard A was 75 and this one's 150, there's another 75 RPM between them. Then retard B appears to be about 15 degrees of timing out the whole ramp. You can see they're both here. So what will happen then is if you exceed retard A line, it will step out 4 degrees immediately. And then if the drive shaft continues to accelerate towards the retard B line, it will start ramping the timing out towards that max value. So for this example, we'll say that it encountered wheel speed and retard A didn't do anything to stop it. It's continuing to spin up faster and faster. What will happen is the timing will go to take 4 degrees out of whatever the base value is, and then it will continue to ramp its way down until it touches the retard B line. So it would take 15 out at this point when it is on retard B at that timestamp. If it gets halfway between, wheel speed stops, it starts to recover, and it's just hovering between the two lines, the timing will just hover between them. And it'll slowly bring it back in until here, and then it will step back to full timing at that last bit. And lastly, there's the rev limit curve, which is 0 on this. 0 disables the rev limiter. So Doug drives a nitrous car. Rev limiters tend to be bad when you're on nitrous, so you don't want to use them. So otherwise, what would happen if he had been using the rev limit curve, it would then, if it passed retard B, it took all 15 degrees out and it continued to go. As soon as it passed retard B, it would drop 1 cylinder out of the car. So you'd have a rev limiter on 1 hole. If it continued to go and got about halfway to, it's divided up in fourths, we drop up to 4 cylinders. So what will happen is by the time it hits the rev limiter curve, it will be dropping 4 holes. So as you step through each quarter between the rev limit B and the rev limit curve, retard B and the rev limit curve, it'll drop 1 hole, 1 additional hole up to 4 by the time it hits the rev limit curve. That part of the traction control has actually proven to be pretty effective from what I've seen. So it looks like he's using it for about 2.5 seconds into the run and then just disabling it from there. So that's where, if you look, we'll go to the outputs and we're taking over and using a wheel slip configuration, front versus rear wheel speed. So what we did is we set up a wheel slip output. What we did is we took a PWM output table, configured it. So this is now wheel speed traction control. We're switching away from the drive shaft based for a minute. So what we did is we took front wheel speed RPM and rear wheel speed RPM. And what we did is we ran the math. It looks a little funky in this table, but if you were to actually run the math of wheel diameters and everything, it would come out to each cell is equal in speed through the center here. So this one we have rear wheel drive shaft RPM at 3582 and front wheel speed RPM at 1015. If we ran the math, those would both equal some number, 60 mile an hour, 120 mile an hour, etc. But it would be equal, there'd be no slip. So that's 0. Then what you can do from there is you can very easily calculate how much slip there would be and fill the table in. One key on this is if you don't fill in these negative values on the other side, it will always see slip because of interpolation. So at some point, it's always going to end up right in the middle of these 4 cells, assuming no slip. So you're going to run right through the center here, and it's going to take the average of all 4 cells. So if you have 3 zeros and one 9.1, you're going to get some amount of slip detected. So you put the negative 9.1 out to make the average go back to 0. So that's the one key to this table that you need to make sure you do, otherwise it won't work properly. So now we know wheel slip. We can calculate it, it's in the data log. What do we do with it? We can go over to the advanced tables. I believe we did a 2D on this one, yes. And we set up a timing offset in this case with the axes being front wheel speed RPM, so basically undriven wheel speed, and wheel slip, which is from the PWM output table. What he then did was put a launch enable on it so we could start a timer, and then he used that timer to delay the start of this traction control for 2.5 seconds. We'll see why in the log, but it's because the front wheel's in the air for some portion of the time before 2.5 seconds, so it doesn't work. Then he also had an RPM enable in it. And then in the table you can see that based on front wheel speed RPM and the slip percent, we chose a ramped in value to control the rear wheel speed. So basically we're using this as a timing retard based on the slip percent. The more it slips, the more we pull. And also the faster we go, the more it pulls to some extent. So now we can look at how that looks in the log. Does that log show okay? Can everyone see that? That's worse. There you go, that better? Okay. So what I have pulled up right now is just throttle position and drive shaft speed. So we'll zoom in on what looks like the run because it's full throttle, and I'll just have a look at the drive shaft curve. We see the time's already zeroed. I zeroed out the time based on the release already for us. And you can see the drive shaft curve looks pretty decent. There's a little wiggle here, some wiggle in here, a little ugly there, and then we got a big check, and it looks like the wheel speed runs away and comes back. So let's look at what happened. Now, first thing you look at is engine RPM. What did the engine do during all that? It was pretty flat. So something was going on here. You know, your RPM's going up and down, something's happening. Finally goes up for the shift. Looks like it shifts, goes a little, and then the RPM falls. So we'll look at the first half of the run first, which was, as we saw in the calibration, it was based on drive shaft speed. So we'll take our drive shaft curves. I'm going to back up for one moment. Forgot to show you something. So on the drive shaft speed based, the time based traction control, you can take and set up inputs that take the table values and put them in the log for you, so you can look at what the table was, what your actual drive shaft was in the log together. And what you do to do that is you set up an internal type for the data log, go to configure, and then you'll select one of the TC_ASM parameters. There's _DS for the drive shaft, and then it will label retard curve A, B, or rev limit, and that's just each one from the table, and then the same with CS for crankshaft curve. So what I did is I pulled up retard A and B from the table, and they're overlaid with the same scaling as the rear wheel speed, so that you can look at them and overlay them together. So we'll zoom in a little more here. You can't see the one line real well. The retard A line is basically running through the drive shaft curve. So if we take and look at the drive shaft timing offset, we can see that we were pulling timing throughout that entire first 2.5 seconds of the run effectively. So the traction control was working and making sure his drive shaft curve did what he thought it should do on that run instead of letting it run free. So you can see that it steps it out, and then also you can see in a couple spots like here, it must have kept going a little bit, so it started ramping the timing out further. You can see that it's basically just trying to control that drive shaft through the whole first part of the run. And you can see it turns off right here where the green line goes vertical. Now pretty much that's right at the shift, and you can see that the shift appears to be what caused the big check and the loss of control of the wheel. So the next thing to look at is, okay, what did the wheel slip percent look like? How did it do during the last half of the run? So let's just pull up the wheel slip percent. I'll actually back up a little here to the beginning of the run. So you can see wheel slip is 0%. You can see at launch we get an actual very large wheel slip percent, the pink line. And this is due to the front wheel being in the air. The front wheel's not moving, you think you got a ton of slip. That's why we don't allow it to do anything this early in the run. From there, it would appear it catches, it probably bounces, if I were to guess, off the ground again there, and then finally settles in. As we go through, we can see we're showing roughly 0 for the wheel slip percent through here. You can see right where the drive shaft checks, we get a wheel slip percent, and then through here it actually starts climbing up. We actually get up to about 6% wheel slip. So we can look at the table, and we see that it started pulling timing back here as soon as we allowed it to. And as through the check mark here, you can see that it pulled a ton of timing out to try to control it. And then as we came up through here, it pulled more timing out to get it back under control again and actually brought it back in. We can back up again. Look at the rear wheel speed. Without looking at all the data, you'd think it looked pretty good right up until here. After looking at it, you realize that we actually maintained the wheel speed through here with traction control, and then again, using a different method, managed to get it back under control through here. And one other thing I'd like to show you is the staged injection for V5. So in V5, how many of you have done multiple injectors? 2 sets, 3 sets of injectors? Decent amount, okay, cool. So in V4, you used to have to do it by selecting 3 injector sets. We'll show you that real quick here. What you would do is, you used to go set 3 injector sets. You'd set your injectors to the proper settings. You take the second set for 2 injector sets and you'd effectively zero them out. And then you set up the third set and you'd have a duty cycle for activation. So it would slowly ramp in the injectors. You didn't have precise control of how much it sprayed when. You could just say when to turn on the second set and they'll meet at the end when they're both flatlined out, spraying everything they can. The reason we used 3 injector sets was it allowed us to turn on the 8 and 2 amp mode, like we talked about in the injector driver earlier, inside the ECU. By telling it had 2 injector sets on the first set of injectors, it would run in an 8 and 2 amp mode. You need this when you're running a 700-pound injector or one of the other big atomizer injectors. and that was the way to do it prior to V5. So to take care of that mess, in V5 we went and added the custom injection type. Now you just select the number of injector sets, you go to configure, and then you set up each injector set individually, and we'll show you a table in a moment where you can actually select what to do with each injector. So for this case, I'm just going to act like it's a twin turbo car. We're going to set 2 sets of 700s. One thing on the first injector set, so we're on injector set 1 at the top here. 8 injectors, sequential firing mode. You can adjust this stuff, so it will be pretty nice for you dual fuel guys or blower stuff. You can actually do some interesting things to make them work for that as well. And then the biggest thing here when doing a single set of 700s specifically is it automatically fills in this information. You see it says custom with a peak current of 8.75 and a hold current of 2.5, and then this peak timeout parameter is set to 5 milliseconds. What this is like we talked about previously, with the injector driver box, we were able to hold at a peak current for an additional amount of time, and that was programmable, and we were able to do that when we designed the product. With the injector driver inside the ECU, we don't have the ability to set a hold at the peak current. So what we do is we tell it to target a peak current that the injector won't hit. So the injector will only hit 8 milliseconds, or 8 amps. We then tell it the peak timeout. If you never hit your peak current of 8.75 amps, what do? You wait 5 milliseconds, then drop to the hold anyway. This accomplishes effectively the same thing as the injector driver. That's why we do it. That's why it's that way. Leave it. Don't set it to 8 and 2, unless you're running a smaller injector like a 325 or a 500 maybe. And down here you also have your use for. So for each injector set, you have the ability to use it for the prime shot, cranking fuel, or your individual cylinder corrections, or not, depending on what you're doing. Some applications, if you have a bunch of injectors in a plenum above a blower, something like that, you may not want to use them for individual injector or individual cylinder correction. And for the second set, we'll go through and do the same thing. You'll notice that there's no driver setup on the second set. That's because with this method, it requires you use one of the injector driver boxes. And that is so we could have sequential control of the second set of injectors. One other downfall of the V4 method, the previous method we showed you where you lie and say there's 3 injector sets, is that the second set of injectors shares 4 drivers. So you have paired injection. Now, we did some trick stuff so that your cylinder trim and everything worked properly. It worked really well. But this way you have a driver for each injector, and you can trim them and do everything you need. And you can actually do some other trick stuff with different injector strategies and other things like that now because of it. So since there's no driver setup when we use a driver box, we need to know how to wire it. So we go to the pin map, and previously there was view injectors. You'd wire them up with the old method to these 4 injector outputs. You can see since we've selected custom and set up 2 injector sets, it says not in use. We don't wire to these. We go to the view outputs, and we look at connector J2, you can see that the drivers are there on the PWM minus outputs. So when you wire in the injector driver box or the new harness we're coming out with, it will plug in and use these 8 outputs. If you select 3 injector sets, it will take the next 8 and use them. So you can run up to 3 sets of sequential injectors using this new method. Once you have all of that set up, you can go to your fuel table. You can see your main fuel table looks the same as it always has. It's pound per hour, VE, whatever your choice is. The numbers are the same. It's your total system flow as it always is. What's new is the custom injectors button. If you click that, you'll get fuel tables for each set of injectors. And what they are by default is percent of the total fuel flow, so percent of the main fuel table. So you may want 50-50 injection between the primary and secondary set on a twin turbo car. If you're a blower car, maybe you're going to do it by percent and do 80% above the blower or below the blower and 20% on the other side. So all you do is you just highlight the table and select the value you want. You can also change it to view it in fuel flow, so you can actually look at the pound per hour going into each set of injectors. Or we also added injector duty cycle, so you can have an idea of what duty cycle you're running each injector set at. So depending on your preference and what you're trying to accomplish, one of those 3 modes should give you the information you're looking for. Anything else on that, Doug?
I just mentioned
Dual fuel? Yeah. Yeah, and one of the benefits of being able to do this is you could do dual fuel, which I didn't mention, which in that case you might just go, you have a small set and a big set, gas and methanol gas and E85, whatever it may be. And as you get into boost and RPM, you might just take this base percent. You might be 100%, maybe 0 on that, 0% on the big injectors, and then ramp them up to 100% in boost. Thus, you're switching fuels then at that point, as long as you have 2 fuel systems. If you need to do some offsets for the different fuels, there's always the advanced tables as well, so that you can offset target values for timing, air fuel, base fuel flow. If it's flex fuel, you might have a flex fuel sensor in there. You can use the advanced tables to offset each set of injectors as well. So one of the things we added in the advanced tables is a new table type, which is an injector set 1, 2, or 3 fuel multiplier. So you can choose something and modify a specific injector set on. So if you have, an EGT or a wheel speed or something that you want to put more fuel in one set of injectors, you can use one of these in an advanced table to do just that. Other than that, I think we got a little time for some questions if anyone has something on what we've gone over. In a few minutes here, I'll probably turn it over to Tom Keiss to tell you about our training that we offer at Bowling Green. Yes, sir.
Importing for the CDI 8000, you go to toolbox and import the IOs for the MSD box.
Yes.
It clears out the rest of my inputs that are already in there.
Yes. What you would do in that case, you can either manually enter them, or if you have a second cal, you'll import it, and then you can use the compare feature. So what we'll do is we'll take this one, it's got some IO in it. I have file, so this one is already twin turbo cal. Okay. What I will do, I'll show you something you can do with the comparison function. So we'll add an individual config, IO, MSD Pro 600 channels. All right. It's not going to let me do it in this cal because I have too much stuff set up. So what I'm doing is I'm just finding a calibration. I'm going to add the Pro 600 to it. I'm going to save it. We're just going to call it Pro 600 IO. We'll go back to the previous cal we were using. What I'm going to do is open the comparison feature. I'm going to open that comparison file. We'll go to that Pro 600 IO that we just created. And then under the IO, we'll go to the inputs. And we'll scroll down here to where we added all these other ones. You can see the bold number is a difference. So what we can do is then click on it, copy to base, and roll through that. And if we go to the inputs now, you'll see that they've been added to your calibration for you. And you can do that with any of the parameters in there. So if you've got 2 or 3 tunes at the racetrack where you've got some good power management, maybe you cleaned up the base fuel table in one of them, but you want to go back to your timing retard, you could open that up and just copy it in real quick that way too.
It's a very underutilized tool.
Yeah, there's a lot of power in this thing, and it can do a lot. We allow up to 4 calibrations to be imported. If we go to the fuel table here, look at the base table values. you'll see that we show the difference in the axes values, and then we'll also show a difference in the table values. So right now, the table is set to show the comparison values. We'll look at the base values. We can look at the delta, or we can look at the percent difference. And the same with the axis values. We can look at the comparison, the delta, or the percent. You can also change the heat mapping, which, depending on your color choice, works or doesn't well. There you go. So now that kind of shows some of the difference for you. You can just turn it right off too if you don't like it, which I should also note, that is a feature everywhere in the software now. So if you right click on a table, you can enable or disable the heat map. And then also if you'd like to add different colors, you can do that anywhere in the software now. Does that answer your question? Cool.
Thank you. How y'all doing?
Great.
Can y'all hear me in back? If I use a microphone, y'all need earplugs. I tend to talk a little loud, I've been told. I don't know what they mean by that, but I tend to boom a little bit. Anybody in here been through the Holley EFI training course with me at all? And been to the EFI course out of Havasu with Ben? A couple of you guys been out there. Raise your hand if you feel that it's an added value to your program learning EFI. So we appreciate that. So a lot of folks don't know that we offer factory direct EFI training for the Holley EFI systems. We've actually been doing it since 2013. As the system's grown and advanced, the classes have as well, including a change for 2020, where previously, if you were to take all 3 tiers, it was 5 days. We've pretty much, for lack of a better term, we've added 10 pounds of turds in a 5-pound sack with the system's capabilities, which has expanded. So the curriculum's shifting a little bit in 2020. The tier 1 class is going from 1 day to 2. So if you were to come in and take all 3 tiers, it's 6 days of training. Each tier is a cost of $299. Includes your manuals. We feed you pretty darn good when you're in there. And I'm going to try to impart as much, whether useful or useless wisdom, however you see fit, that is in my head, into your brains in the time that I have you guys. The classes primarily are hosted in Bowling Green, Kentucky at our corporate headquarters. I hold the classes at the National Corvette Museum. It's a pretty nice little environment to have the classes at now. I have been getting a lot of folks asking me about Havasu classes. Some guys have noticed that the 2020 schedule's out. We are actively taking registrations. The goal is to have a class as well as we usually do at EFI University with Ben Strader and his group. I have not been able to meet up with him yet. I usually talk to him at SEMA. I did not go this year, so at some point this weekend I will meet up with Ben. We'll try to hammer that out. So you guys are looking to do it West Coast. I hope to have dates for that posted here by the end of January. So if you guys are asking about it, we've had a lot of calls and have gone into tech. We're working on it. We just don't have the dates yet for that. If you're new to Holley EFI, you don't have to really be concerned when you're coming into class or new to Holley EFI in general. We pretty much start at the basics. So the first class is what I call Tier 1. It's going to be a 2-day class. It covers basically on system overviews, wiring practices, system setup, general programming. We pretty much focus on a plug-and-play type of installation. So if you have like an LS engine, we're going to cover the plug-and-play ignition types, single injector sets. We don't go way down rabbit holes. We kind of identify rabbit holes within that class. Some of the curriculum changed into 2020 from the Tier 2 class. If you guys have taken it and you're looking to come back, because I do get a lot of guys that retake the classes over. The traction control, I apologize, but the drive-by-wire throttle control, transmission control, and data logging is moving into the Tier 1 class. Advanced tables are moving into the Tier 3 class, and what that's going to allow me to do is slow the Tier 1 pace down a little bit, and so it's not as just wide open throttle as it has been. It'll also allow me to slow down the pace at Tier 2, which the goal of that is to allow me to spend a little bit more time on custom inputs or outputs. I'm assuming Ryan's probably covered some of that. There's definitely a lot of room in there to have discussion. The problem is the way the class was and everything was added, I didn't have the time to get as in-depth in that as I want to. So when we get into Tier 2, it's going to get into some of the stuff Ryan had talked about, utilizing the multiple injector sets, custom ignition types, custom IO, a lot of the outside of the box and things that you can do with the system capabilities that are in there. Some more advanced discussions, more in-depth discussion on some engine physics, tuning principles, theory, processes that you would go through. The Tier 3 class is going to primarily be power adder based and advanced. That's where we're getting into the boost control, dealing with nitrous controls, water math, the advanced tables, the new internal active speed management. Some of the traction based stuff is in the Tier 3 class. And I've already been, I'm assuming you guys have too, when we guys asked about the electronic wastegate, so when we get a better handle on that, I have been asked that. I have no idea how many times down there this weekend. So that will be integrated in there as well. How many of you guys have experience with PID tuning? Like PID boost controls? That's one of those things that I could sit up here and draw and put charts on a board all day long, but until you actually put your hands on it, you do hands-on with PID tuning, and understand cause and effect. It's something that eludes a lot of people, and that's one of the things in a Tier 3 class we spend quite a bit of time on as y'all get your turn at PID tuning on boost control. And I have a little bit different approach, and you guys have already been through it. We start by having it all screwed up. So we teach you how to identify the anomalies and the cause and effect of the things that aren't right, which makes it a lot easier for you to take things that aren't functioning properly and go backwards into making it correct. If you can figure out how to take something that's screwed up and fix it, it makes starting it the right way and approaching it from the direct angle a whole lot easier. So that's one of the things that's tied in there. All of the classes for 2020, the Tier 2 and Tier 3 classes, the price hasn't changed. They're $299. The Tier 1 did go up a little bit on it. The registration is online. If you go to Holley's website, you go under support. There's a link in there for training events. It'll have the current schedule. It'll show you how many seats are available, and there's a direct online link. I have some cards up here that have contact information for us at the training department, as well as 2020 schedules and a printed overview of the classes if any of you guys are interested in getting some of that. But you can simply go on, sign up on your laptop. You can sign up on your cell phone. We've made it pretty intuitive and straightforward. If you sign up for a class, this is going to sound kind of silly, but you're going to get an email. An email is going to be your receipt and an overview, and there's way too many people that I've dealt with that don't like to read emails. Read it, because I get calls all the time. What time's the class? Where do I got to be? Are there any local hotels? There are directions. You have maps. If you click on the email and you open up, there's links. You click on this hotel information, some partners, aerial views, links for automatic maps, and everything y'all need to bring. As far as what you need to bring, I make it pretty easy for you. You need to bring a laptop with Holley software and a pen. If you haven't worked with Holley, it is PC based. So it needs to be run on Windows. I recommend having the software on a computer and getting familiar with it before you come to class. I have literally had folks show up with no laptop. I have had guys show up with a Mac and like, you have the software? Yeah, hand out a flash. This won't work. You know, it's like, well, you have a Mac version? No. What do I need to do? You see the guy next to you, introduce yourself and get really chummy really quick. You might go to Best Buy tonight. I don't know what to tell you when you're dealing with that. But you don't have to bring a whole lot. Try to get familiar in with it. The classes, if you take them all, they are 6 days straight. Pretty much every month I'll have at least a Tier 1 or a Tier 2 class. Essentially every other month I do a Tier 3 as well. You could come in and do all 3 tiers at one time. I call it the gauntlet. Has anybody here done the gauntlet with me? Yeah. How many guys after day 3 your brain was mush? And a couple of you like, yeah, me. I don't really recommend you do that. I do have it that way because there's people, because of travel restrictions, I get a lot of guys that come in from overseas into the classes throughout the year. If it's within your means to travel a couple different times to Bowling Green, what I would really recommend is break them up. It's not that bad if you do a Tier 1 and a 2 class back to back, because you can do them back to back. And then if you come back for Tier 3, one of the things often I recommend is you retake Tier 2 and Tier 3. Tier 2 is a really in-depth class. I guarantee you if you take the time and you take that class over again, you're going to get a whole lot more out of it than you did the first time around. Because a lot of folks come in and they're focusing on one thing. They get back, think their hands is great, but they didn't focus on some of the other stuff. So it will kind of tie in. That's kind of a general overview of what we deal with on the classes. Any questions on the class stuff?
You have to take all, like tiers consecutively?
You do. You have to start with tier 1. There was a time that I would let folks skip tier 1. They said, oh, I got a lot of EFI experience. I've worked a lot with Holley. I'm good. And what I found was 90% of those people needed to take tier 1 because it derailed the heck out of tier 2. I don't care who you are, you need to start with tier 1. Now, once you've completed a tier, let's say you did tier 1, tier 2, tier 3, and you're like, man, I want to come back. I'd like to take tier 3 over again. I want tier 2. You don't have to start back with tier 1. Once you've completed a tier, a level, you can come back and retake levels in any way, make, shape, or form that you want to. But you do need to initially take them in series, and you can do them back to back at the same trip.
Are they mainly Monday through Friday?
They vary on that. Some overlap weekends. I try to get some overlap on weekends. Since it's gone to 6 days, runs through, so some of it's Monday through Saturday, some of it overlaps. You know, try to run some of them over some weekends and some splits.
Thanks, y'all. Appreciate you coming. Okay, thank you. Take care.
So some of it, do you have any of the tier 1s or tier 2s that are off weekends only?
There are some that will fall on a weekend. So, yep. You have questions on anything? All right. If any of you guys want some information on training class, some cards, come up, we'll get that lined out for you. I know a lot of you guys are going out and it's a dying art, it's an EFI deal, but I've had a lot of requests for a carburetor class. So if